JUnit is a habit, not an afterthought. JUnit Conditional Unit Test Execution. Lab 5 Overview. JUnit Conditional Unit Test Execution. The goal of Lab 5 is to use JUnit annotations for conditional unit test execution, and to use all of them at least once during the course of Lab 5. The purpose of conditional unit test execution is to be able to execute subsets of unit tests, fitting a particular condition or a set of conditions. Excuse me. The code for the utility library is available from the course's GitHub account at https://www.github.com/entangolov/GRG-001 JUnit as a habit. You should already have the code for the utility library downloaded for Lab 1. No changes are needed for Lab 5. These are the conditional execution annotations provided by JUnit. @enabled on OS, @disabled on OS, @enabled on GRE, @disabled on GRE, @enabled for GRE range, @disabled for GRE range, @enabled if system property, @disabled if system property, @enabled if environment variable, @disabled if environment variable. We will explore all of these annotations in our lab, and we will explore their applications. Let's get started. In lab number 5, we are going to explore conditional execution annotations. Now, you may have to test your application on various operating systems, various Java virtual machine versions, in the presence of various Java virtual machine system properties, in the presence of various environment properties for the operating system. And JUnit provides a robust set of annotations to ensure that you can do that as required. Let us actually review what we will need for lab number 5. Alright, let's go to unit test code on the project's website, to objects-test.java, to lab 5. You will notice there is no unified div. That is because for lab number 5 we are going to reset the code for our test classes, for most of them at least. And we're going to take the test classes from lab number 1. Alright, and so we're interested in the full file for objects-test.java. But not only. We will need to create 2 additional annotations in the tag.getRealGood.util.test.auxil package. Or we might actually call it tag.getRealGood.util.auxil package. So we might skip the test. Alright, so these annotations are composed by using the annotations for conditional execution that can function as meta annotations. For example, @enabled on OS, @enabled on GRE, and by using @test, which can also function as a meta annotation. And here we have test on not Windows and not GRE14 annotation, which uses @test, uses @disabled on OS, @disabled on GRE. Right, so we need to create those 2 files. We also need to create JUnit-platform properties. And you will notice that I have been silently adding certain properties that we are going to cover in Appendix B. And these properties are commented out, but it's a good place for you to kind of jump ahead and start referencing Appendix B in your spare time and looking at what these properties actually mean. Excuse me, we saw some of these properties in a previous lab, lab number 4, and some of these properties are applicable to Appendix A for parallel execution of unit tests. That's quite an advanced topic, but a very interesting topic, etc. So that is something for you to study if you want. It's not related directly to lab number 5, but it is related to a holistic and comprehensive understanding of JUnit platform. So that's what we are going to create as well within the test folder. Alright, so having reviewed object test.java and the auxiliary files we need, we needed many auxiliary files in lab number 4, we need just 3 of them in lab number 5. Let's take a look at strings tests for lab number 5. Oh, you will notice that objects test.java class itself doesn't contain those conditional execution annotations. What it contains is just the same code as in lab 1. So we are not really using objects test.java class itself. And neither are we using strings test.java class. We are also just using whatever was in lab number 1. So there is no unified div. Neither are we using mass test.java. Let's take a look at lab number 5 for it. We're also using whatever we used in lab number 1, the same codes. The same codes we're using, etc. And we are doing the same for collections tests. For lab number 5, we're not using any annotations for lab number 5. We're just using whatever is in lab number 1. We are doing it. Why we're doing it? We're doing it for completeness. For every lab, we're going to use all the 5 files. We're going to create all the 5 files, even if we're not using all of them. In lab number 4, we were not using collections test.java or arrays test.java, but we're still creating them for completeness sake. All right, let's go to arrays tests.java. And let's go to lab number 5. And you see here that we do have a unified div. This is a unified div as compared to lab number 1's code. We do import some new things and we use the conditional execution annotations here, where the edit code is marked in green. The reason it's marked on 2 lines is the proclivity of Prism.js to add a second line sometimes, but rest assured there is no second line here, just this line. There is also no space here. So for some reason the div editor I'm using did that, so but that's not there really. Alright, so you can see we've added quite a few annotations. Right, in reviewing this unified div, you see disabled if environment variable, enabled if environment variable, etc. Alright, this kind of cuts shorts here due to my div editor. There are some more additions to the file down below that you're not seeing, where I'm using the custom annotations that I composed by using these types of annotations as meta annotations. Alright, and here we have the full file. You can see that I'm using the conditional execution annotations, and I'll scroll down and I'll show you where we're using our custom annotations. For example, add test on Windows and GRG-001 here, and add test on not Windows and not GRG-001 here, etc. So all the new functionality for Lab 5 that we are learning is going to come from arrays tests.java. Okay, this completes our overview of lab number 5, and so in the next video clip we will get started on the actual lab activity. Alright, to continue with lab number 5, we need to create the code that we will use to run the unit tests. Go to the project website, click on unit test code, objects test.java lab 5, scroll down to full file, click on copy, switch back to the IDE, create the Java class, and paste the contents of what you just copied. Alright, let's now go back to again the project website. Let's scroll down to additional action number 2, and let's create, first of all, let's create the tag getRealGood.util.auxil package. Skip on the test text. Let's go to here, click on test, new package, and type tag getRealGood.util.auxil. Alright, there we go. Now we have to create the test on Windows and GRE-14 annotation. Let's copy the name of the annotation. Let's add the annotation within the auxil package that we just created. The best way to do it is just copy this text and paste it in here. Alright, we have created it. Let's go back, let's see what else we need. Let's create the second annotation that we need. Alright, let's create the Java file. And let's paste the contents of the second annotation's code in here. Alright, what's wrong? Of course, I test on, obviously a little bit of an error. It's not an error actually, I think I deleted this by accident. Alright, so we have created the two annotations in the auxil package. Now we need to create JUnit-platform.properties file. We need to create it within the test folder. So it's at the root of our testing effort. We need to create a file. This is the name of the file. And now let us go back, let us click on copy, and let us paste everything that we just copied. Everything is commented out, so it's fine. Alright, so we have created the auxil package, two annotations that we need, the properties file for the JUnit platform. We have created the objects tests. Now we need to create the other 4 top level test classes. Let's go to strings tests.java. Click on lab number 5. Click on full file. Scroll to full file. Click on copy. And let's create strings tests Java class. Alright, and we have created it. What do we need to create next? We need to create the maths tests.java test class. And if you're wondering why it's a little bit slow, it's getting to be about 700 kilobytes of HTML interspersed with the code, and Prism.js takes a little bit of time parsing this code. That's why it's a little bit slow navigating between different tabs. Alright, and there are literally several thousand lines of testing code for each lab times 7. So, alright, scroll down to full file, click copy. Let's go to our test package, create the Java file, maths tests, and paste what we have in the clipboard into this Java file. Alright, excellent. Let's go back to the course's website, click on collections tests.java. Lab number 5. Scroll down to full file, click copy, switch back to the IDE, create collections tests.java class, and paste what we have on the clipboard. Alright, last but definitely not least, but rather the most important test class is arrays tests.java. Well, the most important in the context of lab 5. Let's wait for it to render. Go to lab number 5. Skip the unified div. Scroll down to full file, click on copy, create arrays tests.java file. Alright, and paste whatever we have in the clipboard. Let's see if it automatically picks up the annotations that we need. We'll have to do that by hand. Import class. And we need the second one also to import it. Import class. Alright. And everything has worked out just fine. Let's see here. Well, it's also done. Now let's try to see that everything runs fine. That should be a habit before we start a lab, after we have created all the necessary testing codes. Let's see if our test package runs correctly. We'll wait for the end to finish its thing, and then we'll see what the running of the unit tests provides. Whether the build completes, whether the unit tests run correctly. In our case, they should all pass except a few that should be ignored, and none should fail. Alright, let's see how it goes in the running of the tests. Okay, 3 have failed, and I wonder why they failed, except to say we had that problem. Yes, we had that problem in our lab 1, where there was ambiguity between the invocations of some doubles versus integer, I guess. Codes. Let's add the D at the end. 000 double. 2 0 double minus 2 0 double, and this as well. 0 double and minus 2 dot 0 double. Let's run it again. Right. Now you have to remember that even in the best case scenarios, things will go wrong, hopefully minor things, and you have to be able to be ready to fix them on the fly. You also have to kind of realize that errors are a way of life in programming and software development, and you have to not react to your own errors defensively, but rather proactively and constructively. That will separate you from somebody who is a pain to work with to somebody who is enjoyable to work with. Alright, we fixed it, so out of 214 tests, all of them passed, 14 were ignored as was expected. We fixed the errors, and so we are now ready to proceed to the gist of Lab 5, to the conditional execution annotations. In this video clip, you're going to explore two annotations: add enabled on OS and add disabled on OS. Let's open arrays test.java test class, and let's open the add enabled on OS annotation. We're in reader mode. We can exit the reader mode so that it's more conventional. You see that this annotation can be applied to a type or to a method. It's retained during runtime, and it uses add extend with annotation that we explored in lecture 4, but that we deferred until lab number 6. And basically the way these conditional execution annotations are implemented is via the JUnit extension model. In this case, it's enabled on OS condition extension, even though it doesn't have the extension at the end there. It doesn't have to. Let us take a look at the class enabled on OS condition. It implements execution condition, and the execution condition itself implements the extension marker annotation. It's a marker annotation because it doesn't have any methods or any content whatsoever. It's just a marker annotation to signify that a class or interface is part of the JUnit extension model. We are not going to delve into this right now, and we'll leave it, we'll defer it until lab number 6. For now, it's enough for us to know that all these annotations, conditional execution annotations, are implemented by using the JUnit extension model, and to have some brief idea of how it is done. So it is done with the add extend with annotation, providing a extension class. All right. So having looked at enabled on OS, let's now run this method and see what it does, and you will be surprised, because we would expect it to be enabled only for Linux. However, this method will run just fine, because this annotation will not be picked up if we just run the method the way that IntelliJ IDEA has implemented the JUnit integration. Alright, it runs just fine. Like if this annotation weren't even there. What's going on? Well, the way IntelliJ IDE implements it, it implements it on the type level. If we run unit tests from a type perspective, then all of the unit tests we're interested in will have the correct behavior regarding these conditional execution annotations. Let's wait a bit. Alright, and you see that this method, which says enabled on OS and is enabled for AX or Windows, runs just fine. This method, which says disabled on OS for Solaris, AX or other, runs fine because we are using Windows. This method that says enabled on OS Mac does not run, it is ignored because we are on Windows. This method which says disabled on OS Windows doesn't run properly because, it properly is disabled because we're on Windows, it is ignored. And this method that says enabled on OS Linux does not run because we are on Windows. So that is how enabled on OS and disabled on OS work. You will notice that we can provide for each of those annotations either a single value of the OS annotation for its value parameter, or we can provide a list, like for example we are doing here, and we can provide a single value or a list for both enabled on OS and for disabled on OS. And in fact, let's take a look at the OS enumeration as the last order of business for these two annotations. So you can see here that it has the following values: AX, Linux, Mac, Solaris, Windows, and other. Other meaning if it cannot figure out what the operating system is, it will give you other. Alright, and it has some methods that are not really of interest to us except this method, the parse method, which figures out which operating system it is. And it has also is current OS, basically figuring out if our OS is the one we're running on. Alright, so that completes our study of the enabled on OS and disabled on OS annotations. In the next video clip, we are going to go to enabled on GRE and disabled on GRE. Except to say one last thing. If we use enabled on OS, OS Windows, and disabled on OS, OS Windows on the same unit test method, the disabled annotation takes precedence. If we use more than one enabled on OS annotation with same or different values, only the first one is going to be picked up, that is, and the same for disabled on OS. If we use more than one disabled on OS annotation, only the first one is going to be picked up. Alright, so that concludes our study of these two annotations, and I'll see you in the next video clip with enabled on GRE and disabled on GRE. In this video clip we're going to study the enabled on GRE and disabled on GRE conditional execution annotations. Now, just like in the previous video clip where we explored that enabled on OS and disabled on OS, you can either provide one value or you can provide multiple values of the GRE enumeration. So let's take a look at enabled on GRE annotation. It is an annotation which can be applied to type or method. and which uses the enabled on GRE condition extension. That is how it is implemented. Right, let's take a look at disabled on GRE, and we have the same thing. It's applicable to a type or a method, and it uses it extend with disabled on GRE condition extension. Right, let's take a look at the GRE enumeration. And we have here that it begins with Java 8, Java 9, Java 10, Java 11, Java 12, Java 13, Java 14, and Java 15. And of course, in the future, it will be Java 16 and ad infinitum, and there is also other. And also there is the determine current version method, which returns the version of the GRE. Alright, and now is the time to talk about a couple of other quirks. You can use more than @enabled on GRE annotations on the same unit test or on the same type, but only the first one is going to get picked up. If you're going to mix and match and use @enabled on GRE and @disabled on GRE for the same value, the @disabled on GRE is going to take precedence on the type or unit test you're placing it on. And just like @enabled on OS and @disabled on OS, you can put it on the type, in which case it applies to all the unit tests within the type, except for those where you use dedicated annotations, which override the annotations you placed on the type. So let's see, we have 1, 2, 3, 4, 5 methods in this @nested inner class, and one has enabled on GRE with one value, @disabled on GRE with one value, @enabled on GRE with two values, @disabled on GRE with two values, and well, both of them are Java 14. Let's make it 15 just for the fun of it, and enabled on GRE with one value. So let's see which one of them run and which one of them don't run. Right. Alright, so this one was skipped because it's only enabled for Java 8. This one was run because it was only disabled for Java 8. This one was skipped because it was disabled either for Java 14 or Java 15, and we are on Java 14.0.2 or some other subversion of Java 14. Here it was skipped because it was enabled only for other GRE, which we are on GRE 14, and in this case it was enabled for Java 14 or Java 15, and we are on Java 14. Alright, so that is how this annotation works. Now let's try to remove unit level annotations for the first three classes. Alright, let's set this to be enabled for Java 14. Let this one also be enabled for Java 14. And let's set this to be disabled for Java 14. Alright. Let's take a look and let's see now what will happen. And you see here that strangely all of it runs and disabled on GRE has absolutely no effect. Whereas based on JUnit documentation, we would be inclined to think that this would be disabled, this would be disabled, this would be disabled, this would be enabled, and this would be enabled. So basically, if you mix and match type level annotations, and you also mix in some method level annotations, the system does not look at the type level annotation at all. It only looks at method level annotations, and here there are no annotations. So it runs these methods, and here it's enabled, so it also runs this method. Let's now take a look if we just use a type level annotation and see what happens. Alright, so there are no method level annotations for this nested inner class, only a type level annotation. Let's see what the runtime does. Alright, and it will just run everything, even though it doesn't give any errors. And clearly we here are saying disabled on GRE for this unit test. I mean, for this nested test, we can apply it to a type. Let's try one more thing. And let's place it at the top level class. And let's see what happens here. All right. Is empty tests and is not empty tests. We would expect all of this to not be run, but they will run. Let us now place a test at the top level and see if that helps any. So we see that something weird is going on when we are placing these conditional execution annotations on types. When we are placing them on methods, they work more or less as they should, but when we're placing them on types, they're behaving in a strange way. And we're just looking through all the permutations to make sure that we catch where they work as they should. Right, let's take a look. All right. And we see that even when we have a top-level unit test, the @disabled on GRE annotation placed on the type does absolutely nothing not to run it. So, lesson number 1. The conditional execution API works properly on unit tests, but it does not work properly when applied to types. And lesson number 2, when you're writing an extension on JUnit, to be really careful and to test it very thoroughly. All right. So here you can see that when we apply it to methods, to unit test methods, it works as it should. But when we apply it to a type, it doesn't. Either a nested type or a top-level type. So, is not empty tests. Let's return enabled on GRE. Let's do GRE Java 8. Enabled on GRE Java 8. Java 14. Enabled on GRE. Java 12. Disabled on GRE. Java 8, Java 14. Disabled on GRE. Java 8, Java 12. Alrighty, let's now again run it, having returned this @enabled on GRE and @disabled on GRE to method level for unit tests, and let's see if it works properly. All right. So we would expect this to be disabled, and it is. We would expect this to be enabled, and it is. We would expect this to be disabled, and it is. We would expect this to be enabled, and it is. And we would expect this to be disabled, and it is. So basically, the fact that it says element type, and it's supposed to apply to all the unit tests underneath that type. Unfortunately, it doesn't quite work this way, although it works quite well for element type that method. All right, so we have explored right now 4 conditional execution annotation @enabled on OS, @disabled on OS, @enabled on GRE in this clip, @disabled on GRE. We looked at various usages, at various permutations. We looked at the deficiency of the implementation of the API, that the type level annotation application does not perform as it should. So for now, stick to the method level for this type of annotations. And there are 2 lessons to be drawn from it. One, it uses the extension API, it is really important to really thoroughly test anything that we develop using an extension, and B, the simpler our setup is, the better it will work. Alright, in the next video clip we're going to explore another two annotations: at enabled for GRE range, at disabled for GRE range, and I'll see you in the next video clip. In this video clip we're going to explore two annotations: at enabled for GRE range and at disabled for GRE range. Let's take a look at these two annotations. So enabled for GRE range again is applicable to type and to method, is retained at runtime, and uses an extension enabled for GRE range condition. Here's the extension. The at disabled for GRE range is also applicable to type or method, is retained at runtime, and uses the at extend with disabled for GRE range condition. So that's what it's using. Alright, having briefly looked at it, let's try to test it first of all. Let's see if running just one unit test will work. Let us run this one. Alright, and unlike the first two sets of annotations, at enabled for OS and at disabled for OS, and at enabled for GRE and at disabled for GRE, the at enabled for GRE range and at disabled for GRE range annotations perform correctly. Let's do this. This should be ignored if it performs correctly. And it is ignored. Okay, let's run it at the nested inner class level, and let's see that it performs, that all of them perform correctly. Alright, this one should be enabled, and it is. This one should be disabled, and it is. This one should be enabled, and it is. And this one should be disabled, and it is. Alright, let's see if this set of annotations perform correctly at the type level. So if it performs correctly at the type level, this one should be disabled. Let's check it out. Alright, disabled for GRE range. Let's see. This one should not be disabled, but it is. This one should be disabled, and it is. This one should be disabled, and it is. And this one should not be enabled, and it's not. So basically, except for this one, which we would expect to be disabled, everything performs as we thought it would be performing. leading us to draw the conclusion that the composition of test class and or type and method in application to these two annotations has an additive effect. Let us take a look, for example, for this, to make sure that this is indeed the case. All right. We would expect this to be enabled, and it is. We would expect this to be disabled, and it is. We would expect this to be enabled, and it is. And we would expect this to be well, actually, we would expect this to be disabled, and it is. All right, so for this particular annotation, set disabled for GRE range and at enabled for GRE range, the combination of type applied and method applied annotation is additive, which is a change in behavior from enabled on GRE, disabled on GRE, and enabled on OS and disabled on OS. All right. So the fact that we are seeing these different performances from different annotations that should function the same but function differently should make one a little bit wary of across-the-board application of these annotations to their problem solving, and should make one actually memorize the nuances of the application of these conditional execution annotations. Different types or different kinds of these annotations perform differently. And we have striven in our testing to show that this is the case. All right, so in the next video clip, we are going to go further, and we are going to apply the @enabled if system property annotation and @disabled if system property annotation. Returning to what we were talking in this lecture, just like the previous annotations we covered in this, in this lab, the @enabled for GRE range and @disabled for GRE range annotations are not repeatable. So only the first one will be picked up. If there are two of the same kind on a type, only the first one will be picked up. If there are two of the same kind on a method, only the first will be picked up. The annotations that follow @enabled if system property, @disabled if system property, @enabled if environment variable, @disabled if environment variable are repeatable annotations. So that's the distinction to keep in mind. And of course, it is very important to keep in mind the slight nuances of how these different sets of annotations perform vis-a-vis their type and method applicability. In this video clip, we're going to explore @enabled if system property and @disabled if system property annotations. So I am running a Windows 10 operating system with the AMD 64 architecture. And I would like to enable a test if the Java virtual machine property os.arch contains the string 64, signifying that it is a 64-bit operating system and consequently CPU architecture. Alright, also I would like to run my test only if java.version property of the Java virtual machine is 14.0.2. And in the same breath, I would like not to run this unit test if the java.version property of the JVM is 14.0.2. Alright, let us check at the unit test level whether it performs correctly. Alright, it runs, but this should not run if it performs correctly. But it runs. Alright, we got the same issue here like with the first two sets of annotations. We didn't have that issue with the add enabled for GRE range, disabled for GRE range, conditional execution annotations. We do have this issue again with add enabled if system property, add disabled if system property annotation. Let's check at the type level if we run all the unit tests thus annotated, whether we'll get correct results. Alright, and we appear to be getting them correctly. This should be disabled, this should be disabled, this should be enabled, and this should be enabled. Alright, let us take a look if putting this annotation at the type will cause correct performance. This one should be disabled. Let us check if that is the case. Alright, and here we should be disabled, but we are not. Let me see, what did I put on here? Well, it should be disabled, but it is not. It should be disabled, but it is not. This should be disabled and it is not. And this should be enabled and it is okay. So basically this annotation again doesn't play nice if you try to mix and match type level annotation with the unit test level annotation. And we have to be wary of this as we go forward. Let's delete the type level annotation. Let's bring back the let's bring back the method level annotation and let's run it again. This is something that deviates from JUnit 5.6.2 official documentation. This is something that is unfortunate, but something that we must keep in mind if we wish to apply these types of notation in our own testing. Alright, again, these annotations are repeatable. You can put more than one of these annotations, and both of them will be picked up. Right. And what remains for us is to review the actual annotations. You can see that they're applicable to a type, but they don't actually work for a type. They're applicable for a method. They do work for a method. So it is a repeatable annotation. You can see here enable if system properties class, and it extends the extension enabled if system property condition. Alright, it extends the annotation enabled if system properties, so we can have more than one annotation decorating a unit test. And the same is true for the add disabled if system property. We also can apply it to a type, although it doesn't work for a type properly. In fact, it messes it up pretty badly. It does work for the method. It is retained at runtime. It is repeatable. It implements an extension disabled if system property condition, and basically, just a second. And that basically concludes our lab regarding add enabled if system property and add disabled if system property. So please keep in mind again that for this particular one, don't apply it to a type, period. Apply it only at the unit test method level. In this video clip, we'll explore the last but not least standalone conditional execution annotations, enabled if environment variable, and disabled if environment variable. These annotations are, in fact, referring to operating system environment variables, whereas the previous video clips annotations add enabled if system variable and add disabled if system variable referred to, add enabled if system property and add disabled if system property referred to the Java virtual machine properties. So here we have something that should be enabled if the system property GDM session is equal to Ubuntu. This should be disabled if GDM session property matches Ubuntu. By the way, matches, you can do exact matches, or you can do regular expression regarding the previous set of annotations as well. Here, enabled if environment variable if GDM session is equal to unt, includes the string unt somewhere in the middle of its string. And here it should be disabled if the GDM session includes the string unt somewhere in the middle of it as well. So you can tell that I'm living in the Linux world, and still we should be able to test it on Windows as well without any problems. This one should not run if it works correctly the way it should be working, but it runs. So okay, let's go to the add nested inner class level, and let's run it from the type level, and let's see if it runs correctly. So I would postulate we're having the same problems as we had with the 4 out of 5 sets of conditional execution annotation, is that it doesn't handle types correctly. It handles the method level application correctly. So let us see. This one should not be disabled. It should be enabled, and it is. This one should be disabled, and it is. This should be enabled, and it is. And this should be disabled, and it is. Now let's take a look at this. Let's actually do it like this. Let's place it at the type level. So if the annotation at the type level works correctly, this should be disabled. And let us see if that is indeed the case. Alright, and not only does it not work correctly, it completely messes up our method level annotations as well. So let us press Ctrl Z a few times. I think we're a little bit past what we should have clicked. Alright, we're here. So basically, just like the previous annotation, it doesn't support application to types in any way. It only works at the method level. In fact, application to a type completely messes up the method level. Right, let's take a look at the annotations themselves. It is applicable to a type, but doesn't really work for a type. It's applicable to a method and works fine for a method. It is retained at runtime, of course. It is repeatable, so you can place more than one at the same unit test. It uses an extension, enable if environment variable condition. And now let's go to add disabled if environment variable. It is the same ilk of the annotation. It is applicable to a type, but messes up how it performs at the type level. It is applicable to a method and it works well at the method level. It is repeatable, so you can make more than one of it at a unit test. It uses an extension, disabled if environment variable condition. Alright, so having reviewed it, next we are going to go to our custom annotations that we put together by using or composing by composition several annotations that can function as meta annotations together. And in the last video clip, we'll be doing some typing to activate our tactile memory, so we memorize all of these annotations. And I'll also sum it up by issuing a note of caution that perhaps this API, even though it's marked stable, it doesn't work uniformly, and it works a little bit differently than what you would expect from this type of annotations that can be applied to a type or a method, but it turns out that most of them do not work well or do not work at all with a application to a type. Alright, so I'll see you in the next video clip, and thank you so far for your attention. So we're drawing close to the end of lab number 5, and initially I thought it was going to take about 30 minutes to go through all the concepts, but it looks like it will take close to an hour or even over 1 hour to properly explore all the concepts required for lab number 5. Of course, it is unfortunate, but the goal here is not to rapidly go through the material, but rather to study it in depth with the goal of making you an expert or a guru on unit testing with JUnit. And hence the material by necessity is prolonged and is made more and more in depth as required to get a good sense of what it is. In this video clip, we're going to explore making custom annotations by composing conditional execution annotations that can also function as meta annotations. Right, and let us take a look at them. There are tests on Windows and GRE14, and tests on not Windows and not GRE14. And let's take a look at how they are composed. So first we are putting the add test annotation, which can be applied to an annotation type or a method. So we are applying it to annotation type or a method. Then we are doing add enabled on OS, which can be applied to a type, including an annotation type, and to a method. And we are doing add enabled on GRE, which can be applied also to a type or to a method. All right. So in the end result is that we are getting a unit test that should be run on Windows when the Java runtime environment is Java 14. All right, let's take a look at its complement. Add test on not Windows and not GRE14. Again, we are using the add test annotation, and we are using add disabled on OS when the OS is Windows, and add disabled on GRE when GRE is Java 14. Alright, having looked at it, let's again see if the composition of these annotations can be run standalone. And we'll have to run a couple of unit tests to get at that logical conclusion. Alright, and this one runs fine, but will this one not run? This one runs fine as well. So the conclusion we can draw is that if you're composing a custom annotation from annotations which do not play well on types, then we are going to have the same, we are going to inherit their problems. We are not going to play well on types, and we are not going to run standalone unit tests well. So what we need to do, we need to run at the add nested inner class, then it will work correctly as it should. We see here that basically this one should not run, and because we are on Windows and we are using GRE14 and it doesn't run. This one should run, this one should run, this one should run, and this one should not run. Alright. Now let us do the last test. Let us put this annotation on the type. But because it inherits the two annotations which do not work well with types, we expect that it also will not play nicely when applied to a type level. This is important because sometimes application to a type level can save you a lot of typing, no pun intended. Sometimes it kind of complements the method level annotations, but in our case it just simply doesn't work. It causes all the methods to run. Alright, it runs this, and in our case, oh well, we would need to do it like this. This one doesn't run at all because it's missing the test annotation, but will it run correctly if we add the test annotation? Let's see. Well, and it just has no bearing on any unit tests whatsoever if we put it on the type level. So let's delete it. Let's delete that test here. Let's uncomment this one. And let's run again from the type level. And we should see correct performance. So if you are making a custom annotation composed of annotations that work only on method level properly, then you're going to have the same problem on your custom annotation. And that is something to keep in mind as you're doing custom annotations. All right, so I would imagine that it would not be too difficult to come up with a schema, for example, for JUnit, to make sure that whatever you put on the type level either has an additive effect or an intersective effect with the annotations that you put on the method level. Or at the very least, if you don't put any annotations at the method level and just put something on the type level, that it at least performs correctly. So, however, for the 5 sets of conditional execution annotations that we saw, only one of them dealing with the GRE range performed correctly, and the other 4 dealing with the operating system, dealing with the GRE version, just one GRE version, dealing with the environment variables or system properties. They do not play well when annotating the type, but they do perform correctly when annotating the method. So that is something to keep in mind. And whereas we had the GRE range annotations, they perform when annotated at type, and at method they perform in an additive fashion, which was in fact quite nice to see. Alright, in the next video clip we are going to engage our tactile memory to retype each of these annotations at least several times, so stay tuned. So the most powerful memorization facility we have is not our ears or our eyes, but our hands. And let's engage this facility to memorize this conditional execution annotation. Let's retype it. Enabled on OS Linux. I've said it before, and let me say it again. If you can get some software that will allow you to type without looking at the keyboard, that is probably akin to you learning programming, software development, and all of your education combined throughout your life, because it's as much of a time saver as nothing else. All right. That's what I'm going to do. I think after I complete this course for you, is get some software to type quickly without looking at the keyboard and without errors. The key is not to type without errors. Anybody can do it, but it's the speed that matters of typing without errors. Right. And of using both hands and all the fingers on those hands. And as I'm kind of rambling, I'm retyping the annotations and their contents so that your tactile memory memorizes it very well. All right. You can use a little bit of IDE assistance if you like, not for the annotation itself, but for the contents of it. No harm in that. Let's go on. You can either also copy and paste it if you typed it once before. For the contents, that's enough, but for the annotations, please type them completely. All right. Now remember this, we kind of typed additionally, it works in an additive fashion. So we'll keep it. Remember that you typed what enabled or disabled for GRG for the type as well as the method, because it's nice enough to work there. Let's keep this one. All right. You can copy this if you like. All right, here's the enabled one. All right, let's retype enabled for GRG a couple more times. We didn't get to do that a lot. All right, next is enabled if system property. Remember that the matches, well, here it might be better to copy it. Matches can either contain a literal string or a regular expression. And if you don't know your regular expressions to the point where if I wake you up in the middle of the night and you tell me all the regular expression semantics, then I highly recommend you learn it, or at least have a very good reference book close by. Alright. Let's do this. This is an example of a literal value, whereas this is an example of a simple regular expression. Disable the system property. Alright, there you go. Alright, now we have to do enable if environment variable. We've already done named and matches, so we can just go ahead and copy it over. Disable if environment variable. Disable if environment variable as well. Now Linux is so much better than Windows in terms of how it feels at your fingertips, but Windows has been pretty good lately as well. Alright. What shall we do in here? Let's open this and let's do this for thoroughness and completeness. This content within the annotations value attribute should come a little bit easier. Oh, of course. Alright, and last but not least is going to be this one. Alright, and we have completed our tactile memorization, and so we're good to go except for one last thing. So please memorize very carefully that at enabled on OS and at disabled on OS is applicable to only methods. If you apply it to a type which it legally can be applied to, it will not work. Also, please memorize that at enabled on GRE and at disabled on GRE can also be applied to a type, but do not do anything for you when you apply it to a type, so it's only applicable to the method level on the unit tests. To the contrary, at enabled for GRE range and at disabled for GRE range can be both applied at the type level and at the unit test level, and they have basically additive effects in this regard. So if you disable something on the type level but enable it on the method level, it depends if the exact characteristics of your Java runtime environment fall within something you disabled or fall within something you enabled. That will kind of determine whether or not your unit test runs or not. So it is an additive quality. The system takes both your instructions at the type level and at the unit test level into consideration and figuring out whether or not a unit test is enabled or disabled. Alright, add enabled if system property and add disabled if system property do not work at the type level, they only work at the unit test level. And add enabled if environment variable and add disabled if environment variable likewise do not work at the type level, but only work at the unit test level. Likewise, well, I found an error here, hence that's probably we have, yeah, I fixed it. Likewise, if you have composed a custom annotation, it will not work on the type level or work on the type level based and depending on the type of annotations that you're using, in this case as meta annotations, which you utilize in order to compose your custom annotation. So in this case, these annotations do not work at the type level, hence our custom annotation then does not work at the type level. And here as well, these two annotations do nothing at the type level except mess things up, and hence our custom annotation does nothing for the type level and can only be used properly at the unit test method or method level. So this concludes lab number 5. I hope you do not have a lot of circumstances where you have to support multiple versions of the Java virtual machine. You will find yourself sometimes in a situation where you have to support different operating systems. But again, the simpler the better. And of course, Java promises write once, run anywhere. But there are still differences sometimes in code accessing the specifics of various operating systems. So this API comes in handy, and I hope you had a good time learning its vagaries, its intricacies, and its specifics.